Hello, everyone, and thank you very much for tuning into another episode of Cloud Native Podcast. And hopefully, you're actually some of the folks who are really new or wanted to understand the full potential of running WebAssembly workload on Kubernetes. This is episode for you. We already recorded the part one of this episode. We talk about some of the potential synergies and some of the stuff, how you can actually run WebAssembly workload on Kubernetes thanks to the power of and the open source project we call SpinKube that basically is help you allow the WASM workload packaging. So the WASM workload is packaged similarly to the container, but instead of using an OCI compliant in the image, it using WASM module. And the Spinframework schedule and manages the WASM module across the Kubernetes node. It can run these module either as standalone workload or in combination with containerized services. So if you're interested to know more about it, watch the part one of this episode. First thing first, let people know what is SpinKube, and on top, why we run WASM workload on Kubernetes.
Yeah. And I'll step one step further back and remind people what Spin is. That's what we talked about a year ago with Spin. Spin is a developer tool for building sort of serverless function style applications with WebAssembly. So when we're talking serverless functions, we're talking about, an application that is not running, right, until a request comes in, then it starts up, handles the request, and shuts down. So Amazon Lambda is an example of that. Cloudflare workers are an example of that. And Spin is an example of that. So Spin's a tool for developing that kind of application. And the sort of cool thing about Spin is that because it uses WebAssembly, you can write in all these different languages and all have them compile down to the same binary format, and that binary format runs just about anywhere.
Today, we're spending more time learning from my guest some of the real-world implications of WASM and how things are shaping up going forward and what are their predictions look like. So I have super two guests with me, the CEO of Fermyon Technologies and everything you're doing in the WASM work, Matt Butcher. Thank you very much once again. Glad to have you.
Yeah, excited to be here again.
Thank you. And I have Shivay Lamba. We recorded a CNCF Ambassador episode on my YouTube channel, and he is joining us again. So Shivay, can you give us a quick, fresh intro of yourself? Because this is the first time I'm recording full episode with you.
Yeah, absolutely. So I'm Shivay. I'm a CNCF Ambassador, and I'm also a developer relations engineer at Couchspace. And off late, I've been pretty much involved with a lot of WebAssembly at work. I used to always speak with Matt that, I've never had the opportunity to work directly on Kubernetes, on WebAssembly at work, but we have been interacting a lot with American Express and specifically with Cosmonic for getting like an integration build where we now support Couchbase, like how you have key value support within WASI, you can also now support the documents that you can store inside of Couchbase with the help of WebAssembly on WASM Cloud. So it's been a really exciting few months that I've been involved with the WASM community, the SpinKube community, and of course now I have experience of working with WebAssembly at work as well. So super excited.
Awesome, absolutely. And Shivay is also giving a talk, I think, in KubeCon. He already tells me in one of the prior episodes, and I wanted to know more about what it's all about it. But I will start with Matt first, because one of the question I see sometime popping up all the time, when you actually initiate the container in Kubernetes or anywhere, you need some sort of plumbing. Is it your container up and running before the application receives the traffic? And then it's container running inside the pod, then it has own more abstraction, then it's part of the deployment, then it's part of the replica set. So it takes a lot of time. So my idea is to try to understand, let's say if we run WebAssembly workload on Kubernetes is kind of similar to the pod and it's running inside it. Do we still need to understand or need another plumbing for WebAssembly workload?
Yeah, and the short answer is yes, because that's the way Kubernetes works. And the interesting thing is Kubernetes is sort of built like the cakes where you just have layers with frosting in the middle. Kubernetes is a layer cake, right? And so at the very top, you have the YAML processors, and then you have all these operators that are kind of working their way down. And at the very bottom, you have the container runtime. And containerd is probably the most well-known subsystem there. And so the way SpinKube works is that it sits way down, and Run WASI and several other projects that are WebAssembly related work this way. It sits way down at the bottom of the layer cake. And it just starts up the processes that run WebAssembly. But then in order to create your WebAssembly application, you still have to start at the frosting at the top of the layer cake and write your YAML, and it still makes its way all the way through. The thing is, the kind of amusing thing about this is you don't have to replace any of the middle layers on the layer cake. It's just a little bit on top and a little bit on the bottom, and Kubernetes does all the work to kind of fill in the gaps, which, again, I think we talked about it last time. This is what I think the best part about Kubernetes is that it was engineered in such a way that you could do something like this, where you're putting an entirely new runtime inside of it and creating a new top-level application layer, and everything else just works automatically. And so because that containerd runtime at the bottom can run containers, you can just run your containers in WebAssembly side by side by having both of these runtimes installed at the lowest level. And then you just use Kubernetes as it is to do all the rest of the work for you.
Absolutely, absolutely. I think the last time we spoke about one of the beauty, because I was worried during the time of the WebAssembly initially came. I don't want a new ecosystem to learn all the new tools to run WebAssembly workload, because that's going to kill me. And not every developer in this world is quite of a nerdy. They need some family time, and the friend time is there.
Yeah.
Already. So it's a very great thing. It doesn't do anything new. It's still using the same old methodologies, but the new way of deploying application with the new feature set, new capabilities, and new benefits. So I think the funniest experience for me, having written Helm 10 years ago, right, was writing Helm charts to install WebAssembly applications on Kubernetes. And it was in a way like 10 years ago, I never would have imagined that I'd be using Helm to do that kind of thing, right? But that right there is what we wanted, right? It's the knowledge you already have is the knowledge you need to get these applications running. And that, I think, is exactly what you said before. Like, we don't have to learn many new tools. We can still enjoy weekends with the family outside, enjoying life, and use our regular work tools to learn this new system.
And I think, like, just to probably add to that complexity and how SpinKube kind of really helps to make it so much easier with the plugin system, is that if you recall, Matt, like when we had initially the KWASM project come out, even before that, it was such a big hassle to actually go to an individual node and update the container runtime configurations inside of each of your node, where you had to be able to like run that actual WASM workload. But now it's just a few commands and it automatically does that for you. So I think like that's one of the great things about improving the developer experience. And I still kind of remember this discussion that we have had at so many of the previous prior KubeCons and other events that we have met, that of course the way that we think of WebAssembly is that you're not really focusing on making WebAssembly accessible to people, like where we have to directly interact with it. We are building all these platforms, whether it's the Fermyon Kubernetes or WebAssembly platform, or you talk about SpinKube. The platforms are meant for people to use the tooling that is empowered by WebAssembly and get empowered by the tooling itself. So you don't have to understand all the nitty-gritties that goes on behind WebAssembly.
Absolutely, absolutely. And the next question is quite similar to and I go again to the Matt to just shine a light, because this is really a question coming up all time in the conversation in the community as well. So in the container, we have to check what are the images, what are the vulnerabilities inside it. We have to scan all the various different pieces of the container images. With WebAssembly modules, we know it's quite similar. Do we still concern about those things in container images where we know, or is there a huge surface area of attack? We need to minimize the images that nobody actually goes inside and stop debugging it, adding malicious actor software. What are the security concerns people should need to understand while working with WASM-based workloads?
Yeah, and I think this is one of the areas where WebAssembly is actually a simplification of what we had before. So just at a high level, right? When we build containers, we would take a bunch of pre-existing libraries, pre-existing programs. We would package them up inside of a set of gzipped tarballs inside of an OCI image, and then we would push that whole thing out and it would reconstitute them in the cloud. And we invented a number of tools to kind of, well, I mean, tools over the last decades, we've invented a number of tools to sort of do security auditing at each step of the way. So at the very highest level, you have tools like Cosign that are designed to ensure that the thing that you shipped out there is the thing that you built, and tools like that continue to work just fine with WebAssembly as it is today. Right. At the other end, there are all these tools when you're in the coding process, right, that detect vulnerabilities in your libraries. We have our GitHub set up so that it warns us if any dependencies have known vulnerabilities. So on that side of things, we have an existing set of tools as well. The container world needed a set of tools that could inspect what was otherwise a kind of opaque artifact, right? Something that was hard to see inside of. And so they invented some tools there that aren't really necessary for WebAssembly. So in some ways, we keep both the source code side of things where we have to monitor what libraries are used and make sure we're up to date on those. And we keep the part at the top level that says, yeah, the thing I built in my CI/CD system is 100% for sure the thing I'm running in production. And if we can do those pieces, we don't need that middle part as much. So it's a little bit simpler. And also, actually a little easier for developers, I think, to know for sure that what they build is run in production. But that's not to disparage any of the incredible tools that have built for the container ecosystem. It's just kind of one of those cases where they're not as necessary.
Yes, absolutely. And Shivay, what's your experience so far working with WASM-based applications? Do you still think about when you're building some of the application on WASM to think about, how much of the surface area my images have? How do I actually train it to make it? So what you're actually seeing developers are actually struggling with?
No, I think as Matt pretty much mentioned that, first of all, you're never concerned about the actual size of the WebAssembly model, because as we know that it's a known fact that as compared to a typical container image, your WebAssembly module for whatever code that you're packaging together as WebAssembly module will always be smaller as compared to that container image. So I think like that, what makes it super portable. And I think like for me, I've done a lot of my research with WebAssembly around machine learning. And one of the most important aspects of like running machine learning inference on the edge is to convert that machine learning model into a format that can actually run on a variety of different devices, such as like converting into the Onyx format. But of course, when you look about even converting that into an Onyx format, there are certain issues, or like it's not that seamless, because you have to basically ensure that because you can think of machine learning models as graphs. So these graphs are typically using protobuf, which does provide you platform agnostic data, but like it's still kind of hard to handle these Onyx conversions because that's still a static graph representation. So that's where we have implementation of things like WASI NN, which is a standard proposal for performing machine learning inference on WebAssembly. And essentially what it allows you to do is that whatever WASM modules that you have, they basically call the low-level bytes which are required to do the inference. So it helps you to extract your machine learning module from that underlying system. So which means that now you can do ML inference on multiple type of systems because of the capability of WebAssembly, which then provides you much more secure machine learning deployments as well. So compared to like your Onyx related deployments, WASI NN is not like tied to any specific platform. So this basically eliminates the need for doing any sort of model conversion, and also it inherently makes your machine learning inference also more secure. So since we were talking about security, I mean, I've not done a lot of work on that security of, like whether it's artifacts for your registry, container registry, but I can speak more from the perspective of security of your machine learning deployments, which is made super secure with the help of WASI NN.
Absolutely. And I have actually keep up the question in my catalog, and I definitely asked that as well. But I give them a smaller story. I remember back in the day, there's so much concern about the community that there are 250 megabyte images. And I work with the Windows application where 2.4 megabyte of the images. And I remember back in the day, some of my team leaders say, oh, this is not, we have to suppose run actually application on any production server with 2.55 GB of the image. So what I did is actually take up a WASM application, and it is just telling me 4 KBs. I was literally stunned by the image size. And my boss said, how the hell you do it? I said, this is not container, this is WASM. But on that day, I remember there's so very sophisticated way to run actually on Kubernetes. And we actually chatting about quite recently, saying, oh, now we actually run with the SpinKube. And he's very delighted that we actually came up with this kind of scenario. So I think this is a really innovative space. People were actually previously struggling to run workload using Kubernetes. So Matt, as Shivay is experiencing some of the machine learning capabilities, I want to learn from you on the community side and also on the customer side. Like, what is the actually you have seen in the generative AI space, some of the use cases, given the current landscape today in the WASM, when do you think, or is it actually happening that you see a broader adoption of WASM for AI workload, for specifically in the enterprise environments?
Yeah, and I can give an intro, but Shivay is more of an expert in this one than I am. What we noticed early on is that WebAssembly is a good way to optimize for compute resources, right? It is lighter on your CPU. You don't have to claim CPU resources for as long. It's often lighter on memory. And then as LLMs started to get popular and AI started to get popular, we noticed that a lot of the same advantages accrue on GPU too. So if you're focused on cutting CPU costs and then all of a sudden GPUs get thrown into the equation and are 10 times more expensive than a CPU, for us, our eyes lit up and we said, oh, this is going to be a great use case for WebAssembly. And so we did a lot of exploration. We of course do support a couple of large language models inside of Spin. For us, what we noticed was there was a particular class of serverless workloads where being able to start up an application, do an LLM inference, return the results back to the user as fast as possible, and then free up the GPU resources for another query by another user. That saved money, saved time, and was generally an easier developer experience along with it. I'd have to defer though to Shivay to kind of dive into the depths of what all can be done here and what's sort of state of the art, because I think Shivay is a little farther along than I am in understanding and using this for.
No, I think like you put it all very well, Matt. I think just understanding, because even I have done so much of tinkering around with the Spin, with Spin, not SpinKube, but with Spin for machine learning workloads, whether it's the AI inferencing. So what you typically would do is that you would download your actual model file inside of your directory, and then you'd use the inference with that. Now, of course, one thing to keep in mind is that, again, at the helm of all of this is your WASI NN, which is your standard WASI API for performing machine learning inference. And that's pretty much what drives most of a lot of these conversions, because with WASI NN, it is essentially providing you an entire ecosystem to train and use models. So whether you have models from TensorFlow or PyTorch or Onyx, whatever type of model category that you have, you can just use that same format and convert it into the format that's specified by the WASI NN, because it provides you a set of APIs which allow you to then do that inference on any type of workload. And also, like when you talk about machine learning, right, there are different kind of hardware acceleration, because normally if you want to make machine learning inference, and especially like LLM inference, even feasible on any type of device, the nature of machine learning inference, whether it's like running a small LLM or a small model, it makes it amenable for hardware acceleration. And like without hardware acceleration, then inference will be too slow. So even the hardware acceleration, when you talk about it, whether it's SIMD support or GPUs, TPUs, like there are different kind of hardware accelerators that are out there. So how do you make it possible so that you can run that same machine learning inference code, but not have to convert your model to be support for all these different kind of hardware accelerators? And that's where WebAssembly programs capabilities come into picture. So just imagine that WebAssembly programs that want to use a host's ML capabilities can basically access these capabilities through these by having that support for WebAssembly with all of these different accelerations that we have, right? So when you take your original machine learning code and you have that inference code and you wrap that inside of a WebAssembly module, now you can just leverage any of these particular frameworks that are supported, because like WASI NN backends correspond very easily to different kind of machine learning frameworks. And then that same API can now interface with all of these different hardware accelerations, which are supported natively inside of WebAssembly. So you just have one platform, which is the WebAssembly module, and you can do your inference across different kind of device architectures. And again, do it very quickly because of the small size of these WebAssembly models. And that reminds me again that, because I've seen these demos from Fermyon, where you can basically spin up multiple like thousands of WebAssembly modules when you're using Spin, and they'll die like in a matter of a few milliseconds after performing whatever tasks that they have, whether it's a machine learning task or any other task. So I think like that nature of support for different types of system architectures, and which then allow you not to have to convert your model, and then that rich ecosystem of being able to support different kind of machine learning frameworks. That is what brings together and it provides that cohesiveness. And that's like the reason why you can now do LLM inference very quickly. So there are projects like Llama Edge, which use Rust and the use of WASI NN, which then allow you to run LLM inference apps. And again, typically if you think of Python, a Python PyTorch implementation is almost 5 gigabytes in size with all of the dependencies. Whereas now you run that same inference logic instead of WASI NN and Llama Edge, it's just 30 megabytes. So again, you see that comparable difference in terms of how much amount of code you have to pack. And Llama Edge is using Rust. So inference with Rust is multitude faster as compared to using it with Python. So I think like those are a few ways in which, like machine learning inference on the edge, and especially like then LLM inference becomes a lot faster and a lot more compute friendly for people to do that inference.
Yes, absolutely. And I think I remember back in the days when the container initially started. So some people are jumping into the Windows world. And as I mentioned, there's a tons of GB in there. And they see what the hell we're doing on. And then I think Microsoft said, we can't actually trim down the version of our container images. Let's build WSL. So people can still run the images in Windows. And I think the same in the Gen AI, like people developing LLM, and they end up saying, oh my God, that LLM can be portable to the different, because remember in the healthcare app, sometimes he trained the LLM and it can be used in so many different places. So reusability for the enterprises are a very big thing. But with the help of WASM, I don't think any other way today exists where you can actually, the things Shivay can spoke about are achievable without any other technology today. So that's a very greatness that WASM actually being toward as well.
Yes, but again, like one thing to keep in mind still is that like of course there are still a few downsides, right? Like you are not meant, like this entire approach with WASI NN, it's not like meant to do model training, because model training is in its own regard is a own beast. So we're not talking about model training. We are not saying that you are basically taking your entire PyTorch and converting it to WebAssembly. It's just that inference code that you are actually translating. So of course, it's clearly not designed at the very moment for doing things like actual training, or even if you think of like different kind of individual machine learning operations, right? So every single machine learning operation, whether you talk about neural networks, so they'll have graphs, right? They'll have a graph loader, which are kind of the internal working of any typical neural network model, right? So it's not designed to, like, let's say, support individual machine learning operations, because that is still kind of getting up to speed, like, because as you know that, WASI does not support each and every particular, like we still have ongoing support for networking. So of course, we are getting more and more integrations built in for the WASI ecosystem. So there's still like certain things that you will probably not want to do with WebAssembly. But of course, when it comes to like inference, that's where like it's a really good use case. But I just wanted to point that out, like so that people don't think that everything is accomplishable with the help of WebAssembly. There are still some certain amount of limitations with what it can't do very nicely, or it can't do that well as compared to your native implementation. Or probably Matt, if you want to add to that.
Yeah, I was gonna, for those who are listening and still kind of learning about the AI stuff as you go, Shivay is right. You wouldn't do the training this way, but then training is the one-off kind of thing that happens every once in a long while, right? Or some of us just use pre-trained models and don't do much with it. The inferencing part is the querying part of the model, right? And so that's the thing that we expect. For every one time you're doing training, you're probably doing tens of millions of inferences against that same model. And so I think it's, it's always good to point out the limitations of something as you did, but at the same time, it's kind of like saying, well, what we really care about is how portable can we make the querying part of this? How fast can we make the querying part of this? And that's where I think WebAssembly really shines. Even if training is not a thing we ever really get into, I think that's okay, because that's sort of a specialist domain, often very, very intensive. Background knowledge in AI is required to do that. Whereas on the LLM inferencing side, often your, prompt engineering is largely writing sentences and fine tuning that prompt to the LLM. So, good to point it out. I just don't want anybody to think, oh, so it's only half done. No, it's not like that. It's like the big thing you want to do is be able to use these models, and that's what we've really focused in the WebAssembly world on being able to do, is use them.
Absolutely. And Matt actually pointed out wonderfully well, because remember, when you build the container images, it's just one time building the container images and a million time running the container in different places for the different team members.
That's true.
Even though for the WASM, it doesn't train the data, but as Matt pointed out, this has to be used in million different devices. Million people has been using it. They have their different environment. So portability is a big achievement if you actually bring it to it. But Shivay is an expert on this. So if you have more questions, you should talk about it with Shivay as well. So as we are now, Matt, in the October, and I wanted to learn from you is like, what is the current state of WASM today and the next few months, and now in the closing in 2025? What is currently is in the more in the horizon you see as in the community of the SpinKube project? What are the newer feature requests coming up? And some of the implication of some hard pushes from the community. No, Matt, I need this. Make sure the SpinKube should actually give me this kind of stuff. So what are those requests are coming from?
And so between the last time you and I talked, which has only been days now, there was a big, what's called the Plumbers Summit, the WebAssembly Plumbers Summit, which was focused very much on the internals of WebAssembly, and in particular the internals of WASI. Again, WASI, WebAssembly System Interface, is sort of like a set of core libraries that interface with the operating system or underlying system. So you heard Shivay talk about WASI NN, which is the interface to, I think it was originally, NN stands for neural networks, but it's really sort of the WASI AI interface, very broadly architected. But there are others like WASI Preview 2 includes support for file system, for system clock, for a bunch of things. The Plumbers Summit was a group of low-level engineers getting together and saying, what do we need to do to make the next version of WASI happen? And largely, it sounds like everybody's very optimistic about getting the next level of networking support in. Everything seems to be going along very well. So, I think we'll see another version of that happen late this year, very early next year. And that is, so again, WASI uses peculiar language, right? There's P1, P2, P3. Then after P3 comes 1.0. So, what they were talking about is we're just about done with the main version of the specification. For those of you who have worked on specifications, these things take a long time. And at 1.0 is like the big authoritative stamp of approval that this thing is going to be like this for the next 10 years or longer. So they'll hit a major milestone on that one coming up soon. That affects almost everybody who's working in WebAssembly. So that's really fun. For SpinKube, and Spin, we'll be doing a couple more releases this year. Really, SpinKube, the focus is just continuing to integrate with different pieces of Kubernetes so that it works even better and it's a little bit easier to use and a little bit faster. When KubeCon comes up in November, I think it is, we'll definitely have new release of SpinKube up in time for that, so that we can demonstrate it at KubeCon in Salt Lake City in the US. So a lot of good stuff coming along there. I'm trying to think if there's other big, broad WebAssembly. Oh, the other one is the component model has kind of hit some new levels of maturity, and a lot of people are saying, okay, it is now a given. We'll use this component model way of architecting things, and that's exciting because I think all of us kind of advance forward when we can do things like have our Rust libraries talk to our TypeScript libraries and talk to our Python libraries, and really kind of open up some new opportunities there. Yeah, I think it's going to be a very exciting fall for autumn for WebAssembly because all of these things should sort of come together. It's nice to have WASMCon and KubeCon in November as sort of an event where we can all come together and unveil all the stuff that we've been working on for the last 6 months. So it'll be very exciting.
Absolutely.
I think one shout out that I want to give to Matt's team is they really follow this conference driven development. So at every single conference, whenever I speak with the Fermyon folks, they say that they put in all-nighters just before the conference to make this amazing big release. And I mean, that's a wonderful thing. That it's you are driven so much because, of course, like that's one of the best ways to showcase to the right audience that what kind of amazing features that are being built. And in fact, so Matt, I'm not sure if you were aware of this, but when a couple of months back, I was giving a talk at one of the PyCons around like how you can leverage the Python SDK for Spin. So of course, like at that time, because apparently like the kind of Rust library that was being used, it only limited the amount of models that you could use because, like we already had Llama 3 at that point in time, but there's only support at Llama 2 for that for during that time. So I had a conversation with Karthik, and I think like they started to implement a new type of model conversion library in Rust, which now supports a lot more number of models because I feel like Spin as a way that with the ease at which you can deploy serverless AI applications, whether it's LLM inferencing, it just makes it sense, right? That the more amount of custom models that one can achieve and one can then use with Spin, and then potentially then deploy it on SpinKube, because I feel, and probably like Matt would love to know your thoughts. I certainly feel that as SpinKube itself is growing, there might be a lot more examples propping up, and something that I'm also like personally kind of looking forward to is a use case where we have support for WASI. With WASI, you have support for WebGPU, because like that's also like something that's boiling up right now, where the WebGPU core spec APIs are slowly but steadily getting added and getting support. Like we are adding support for them inside of WASI. So an environment where now you can use a Kubernetes cluster and deploy machine learning workloads with the help of SpinKube, and then have native support for GPU bindings inside of those nodes with the help of the WebGPU interface with WASI. Would love to know your thoughts about that kind of future.
Yeah, and it's always fun for me to talk to somebody whose expertise is very much in the AI and the WebAssembly stuff together. Because I know Shivay, when Shivay gave this presentation, Karthik from our team, who's one of the engineers who has worked the most on LLMs on our side, came back very excited and said, I think if we just switch from this library to this library, suddenly we'll be able to do all this other stuff that we haven't been able to do yet. And so, we always look to you to kind of see what state of the art is and what we should be pursuing. Because I think you're right. I think we saw some early hype on AI that was then followed afterward by everybody going, but what do we do with it? Right? It looks really cool, but we're not sure what we do with it. Now we're getting to the point where people are saying, I've got ideas. I know what I want to do with this. I want to try this. How am I going to run it? And where am I going to run it? And so we're, I think, learning now, how should this look when it's running inside of a Kubernetes cluster? The first wave of GPU access in Kubernetes was a little resource greedy. And now we're kind of learning again. Okay, well, this is how we can do it a little bit better. Here's the way we can do it even a little bit better than that. And so I'm excited about, the next year or so as use cases actually start to come together with where we've theoretically been talking about things, and we learn a lot about how to run these things in production, particularly in Kubernetes.
Yeah, and I think like that's where I'm also excited on the other side of the GPU management itself. Like now, of course, we have had MEG support, so multi-instance GPUs, GPU sharding or time slicing, like whatever those techniques are generally with which you are able to distribute your GPUs. And so many companies are primarily focusing on being able to do that for AI workloads. So in like kind of interfacing that with your SpinKube application or like any kind of whether you're running your AI applications with the help of WebAssembly or non-WebAssembly workloads, but just the entire ecosystem of GPU scheduling and dynamic resource allocation, because those are like the other kind of really impressive things that are happening right now on the Kubernetes ecosystem side.
Awesome. So actually, when Shivay and Matt actually talk, I don't want to interrupt, but we have to wrap the episode. It's been a great talking to you as well. So I think the potential of the WASM is really experimenting all the time, because I'm actually not the fan of adding plumbing logic for the container, where the container first came up, then the application should write the traffic towards to, and sometimes there's auto scaling. Oh, my container is now into the new node. Now I need to do the re-plumbing for the new node. That is a big worry in the auto scaling world, specifically in the DevOps side as well. So I will wish, and I'm seeing, I have hopes WASM will actually not made me think about what the hell is happening inside the board. Just give me up where the compute is available, and I know how to run, how long I run, and I will tell you. And also the one thing I really like about SpinKube, and in some of the Open Telemetry conference happening, a lot of the talk about WASM and its integration with monitoring. So one of the things I like about the SpinKube tool is you can use the same Prometheus and Grafana things for monitoring the WASM-based workload. So that's a really shining thing as well. But it's been a great talking to you, both of you. So I include the link for the Shivay talk. I'm really hope everybody attending should go. And the WASM, I think, is happening in WASMCON as well. Also in the KubeCon in journal. Shivay is giving some talks there. He already shared with me on one of my short videos what he's talking about. So I will include the link. You should go and listen to some of the episode as well. And if you're actually completely new to the SpinKube framework and SpinKube open source project in general, watch the first episode with Matt I did, because we covered some wonderful ground. What is SpinKube? And you can run it on K3s, rancher-based clusters, and also in some of the Kubernetes style you already been actually familiar with. So it's not any new learning curve, not new command. It's just anything you're familiar with, but now you're running something extraordinary with, once again, kubectl get pod. And now you see what the hell WASM is doing as well. So that's the little thing I really shine about. And I think there are tons of congratulations to all the engineering team behind that who make that possible, because I wish to extend Kubernetes to do what I like to do, some of the stuff I want to achieve with it. So that's a great thing about. But now we're top of the hour. And I hope I will sometime connect back again with those two guys, because they always have a fluent knowledge on the state of the art WASM. So it's love to know about what's happening. And now Shivay is actually correlation between generative AI, the buzz around Gen AI, and how you actually can cut compute cost with WASM. So that's a very interesting space. So as always, love talking to you both. So hope to meet you sometime in the near future as well. So stay safe, everybody, and stay caffeinative.